Hello students, today we will do exercise 1.1, question number 6. Matrix A is 8, minus 4, minus 5, 3. Verify that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I2. I2 means identity matrix of order 2. A is 8, minus 4, minus 5, 3. Now we have to find, that is given, so we have to now find adjoint of A. You know how to find the adjoint of A? The principal diagonal elements, just switch those, swap those elements, and the other elements, the other diagonal elements, change the sign. Okay, so the principal diagonal, switch or swap the elements, the other diagonal keep as it is but change the sign. So we get this. Now find determinant of A, that is cross multiply 24 minus 4 into minus 5, that is 20. So 24 minus 20 is equal to 4. Now we have to multiply A matrix into adjoint of A. So you have to multiply the matrix A. Matrix A is 8 minus 4 minus 5, 3. Adjoint of A just now we found 3, 4, 5, 8. Now we have to multiply using matrix multiplication method, first row, first column. So 24 minus 20, that is equal to 4. Then 32 minus 32, 0. Minus 15 plus 15, 0. Minus 20 plus 24, 4. Okay, so we got 4004. Now let us find adjoint of A into matrix A. Adjoint of A into matrix A. Okay, we'll name this previous one as equation 1. So how do you find adjoint of A into A? Adjoint of A is 3, 4, 5, 8. Matrix A is 8 minus 4 minus 5, 3. Just multiply once again using the multiplication method. So you 3 into 8 minus 20, that is 4, and minus 12 plus 12, 0, and 40 minus 40, 0, and minus 20 plus 24 is 4. So A into adjoint of A and adjoint of A both are equal, that we have proved now. Now we have to find determinant of A into matrix I. Okay, so we have to find determinant of A that we already found. That is equal to 4 into I2 matrix. I2 matrix is identity matrix of order 2. So 1, 0, 0, 1 into 4, that is equal to 4, 0, 0, 4. Okay, that is equation 3. You can write it. So we proved now A into adjoint of A into A is equal to determinant of A into I2. So we have proved that these three are equal. Is it clear? Okay. Now we'll move on to the next sum. Question number 7. AB is equal to 3, 2, 7, 5. Matrix B is minus 1, minus 3, 5, 2. The question is find AB inverse and prove that is equal to B inverse A inverse. Okay, let us first multiply A into B. Okay, so there is a left hand side, matrix A into the matrix B. Into inverse we have to find. So multiply normally 3 into minus 1 plus 10, that is 7. 3 into minus 3 plus 4, that is minus 5. Minus 7 plus 25, 18. Minus 21 plus 10, that is equal to minus 11. Now we have to find AB inverse. We have to find AB inverse. But how do you find AB inverse? You already know the formula. What is the formula to find A inverse? What is the formula? A inverse is equal to 1 by determinant of A into adjoint of A. A inverse is 1 by determinant of A into adjoint of A. So in the place of A, you have to write AB. Wherever you have A, write AB. So 1 by determinant of AB into adjoint of AB. So let us find determinant of AB. So already we found matrix AB. So minus 77 minus 90, that become plus 90. Okay, minus 77 plus 90, that is equal to 13, and 13 is not equal to 0. That's very important. You should always write, whenever you have to find inverse, you have to find the determinant not equal to 0. Therefore, AB inverse exists. AB is a non-singular matrix. That is why AB inverse exists. Okay, so you should write that condition. You should write it's not equal to 0. So AB inverse exists. Now we have to find adjoint of AB. So adjoint of AB, you know how to find. Just interchange those two elements of the principal diagonal. So it will become minus 11 and 7. The other side, keep as it is but change the signs. Okay, so it will become minus 5 and minus 18. So AB inverse is 1 by, you already found the determinant of AB, that is equal to 13, into the adjoint of AB, that is minus 11, 5, minus 18, 7. So we have found AB inverse. Now what is the RHS? B inverse, A inverse. Okay, RHS is B inverse, A inverse. So we have to first find B inverse. So B inverse is 1 by determinant of B into adjoint of B. Okay, 1 by determinant of B into adjoint of B. So what is the matrix B? Minus 1, minus 3, and matrix B is minus 1, minus 3, and second row is 5 and 2. So just cross multiply, minus 2 minus minus 15. So minus 2 plus 15, that is equal to 13. And that is not equal to 0. As I told you, you should write that is not equal to 0. So B inverse exists. So because B inverse exists, you can find the adjoint of B now. Then find B inverse. So adjoint of B, as you know, interchange those two numbers and change the sign. You get 1 by 13, 2, 3, minus 5, minus 1. Okay. So now we have to find that A inverse. So matrix A inverse you have to find. So determinant of A is nothing but, just multiply the diagonals, that is 15 minus 14, that is equal to 1, not equal to 0. So A inverse exists. Now we have to find adjoint of A. So interchange the diagonal elements, change the sign of the other diagonal elements. So we get 5 minus 2 minus 7, 3. Okay. Now we have to find B inverse into A inverse. So 1 by 13 into, here in this case A inverse is adjoint of A itself, because the determinant of A is 1, right? Determinant of A is 1, so adjoint of A is equal to A inverse, because A inverse formula is 1 by determinant of A into adjoint of A. So let us now multiply. So you can just see that A inverse and adjoint of A are equal. Now multiply 1 by 13 B inverse into A inverse. Okay. So we get the answer 1 by 13 minus 11, 5 minus 25 plus 7, that is minus 18. Then 10 minus 3, that is equal to 7. So we got B inverse A inverse as 1 by 13 minus 11, 5 minus 18 and 7. Okay. So we have proved that LHS is equal to RHS, that is AB inverse is equal to B inverse into A inverse. That's hence proved. Yeah.